trying to get further on the water bath project. That water bath had to heat up a substantial piece of water, say in a big pan, around 38 degrees Celsius. And this is a kind of experimental setup, and I also have made a few bottles inside a big pan and then a 1000 watt heater under that big pan, and then the whole circuit worked quite good. So first advice is, by the way, when you don't have any idea about electronics, etc., don't make this circuit. It is experimental. I don't want to discourage experiments, but I found in practice that there are so many parameters here in this circuit that it's a difficult circuit. Both the supply voltage, for instance, the voltage that is generated here by the germanium transistor immersed in that water bath. There is of course a certain volume of that water bath, not water bath, but the water. It heats up quickly now in this experimental setup, but when you have a big pan, the water will upheat very slowly. But say I only want to give this, say, as a kind of idea when you want to do experiments. Anyway, you can use such a thermometer that I bought today, and there's also an old one. That's this one. Say it's a temperature meter that can give you a very good idea about the exact temperature of the water bath. And it has to be 38 degrees, around 38 degrees Celsius for photographic purposes. But anyway, so this is a good idea. I also have another thermometer here. It also works quite good. And I have also another thermometer. I cannot show it at the moment, but that thermometer is, say, immersed into the pan and not into the water, but into the flasks that are heating up and have to be heated up around 38 degrees Celsius. So anyway, this is the first experimental schematic that has a little bit of success. And I can show it here. And this is the schematic. At first, important to tell that you don't need a stabilized voltage. That's very important, because otherwise the change in the voltage that is given out by the heat sensor, that is the germanium transistor here. When you have a stabilized voltage here, it will the stabilizer unit will try to keep this voltage constant, and that's not good, because it has to change regarding the temperature. So that's the first advice. And when you are a little bit acquainted with electronics, you can say, well, what's the function here of this field effect transistor, the BUZ80? It doesn't have a function. But I tried it over and over, and I've also taken out this field effect transistor out of the circuit, and the whole circuit did not want to work properly. Especially kind of thermal run out to 45 degrees Celsius perhaps even 50 degrees Celsius, but anyway. I'm talking here about a voltage divider. This was originally a 470k potentiometer, and the wiper goes to the base, but now I've changed it into two resistors of 220k, and the reason is that I only want to have one potentiometer to set the temperature. In this range, by the way, the whole circuit only works around 38 degrees Celsius. Perhaps going to 45 degrees or 35 degrees, but that is the range for this circuit. And here we have the same situation. When you want to do experiments, change these two resistors here into a potentiometer of 470k, and also here 470k. So that was my idea, say, to skip all the variables, the variable parameters out of this circuit to make it work better. This capacitor here sets in a certain way the switching time when the critical temperature is reached by heating up the germanium transistor. So on a certain moment you will see that the whole circuit will start to switch and click. It clicks on and off. It heats the element, the heating element, on and off during, say, approximately 1.5 minutes, and after that the heating is the water in the water bath is heated to a proper temperature where it all works. And I mean where you can see that inside the flasks in that water bath the temperature is around 38 degrees Celsius. So this is what I have done, an experiment in the past. I hear in my kitchen a kind of beep. Sorry for that. I have to switch it off. It irritates. So I have put, say, a few glass bottles here, 4 bottles, in that pan, that big pan, that was filled with water. Under that pan there was a heating element of 1000 watts, and that was this heating element, this one. It heats up the big pan where the 4 bottles are immersed in the water. In the water there is that heat sensor, etc. So this pan is heated up and switched off and on with the help of the circuit. And I have to say that it worked quite good. But now I'm on a, say, second stage of this experiment, and so perhaps I have to pan over somewhat. I have immersed inside one of the bottles a thermometer, and it held it on approximately 38 degrees Celsius. That was quite good. This is, by the way, an indication of how the one of the potentiometers was set to a certain point where all worked fine. But I leave this idea, by the way, because such a potentiometer, when you have such a potentiometer, say this one for instance, say this one, could also be another one, the contact to the carbon layer is never very precise, and on the longer term it can corrode. That means that the whole circuit doesn't work. So I want to skip as many potentiometers as possible, but the other side of that experiment is that you have to search for very exact values of of resistors, fixed resistors, where this wants to work or not. My camera will stop within a minute. Thanks for watching. This is the schematic again.